Hello student, welcome to a study doubt. This question is from physics chapter magnetism. In the question it is given that two particles of mass m1 and m2 have equal charges. They are accelerated from rest through the potential difference V and then enters a region of uniform magnetic field B. If they describe circular path of radius r1 and r2, then what is the ratio of m1 by m2? So let's understand this question with a figure. As you see, this is the magnetic field. Here is a magnetic field. And this is a cross we are considering. It means that it's going away from the observer. Now we have two charged bodies of same magnitude. Let's consider this as a small q. And the masses are different. This is m1 and here it is m2. Now when we apply certain work on it, and this charged particle started moving with certain acceleration. When it reaches in the magnetic field, it starts forming a circular path. Why it is forming a circular path? Because when the charged particle is moving, its velocity is along x-axis. And magnetic field is going away from the observer, so it is z-axis. So now where is the force? Force is along y-axis. So this force continuously acting on this charged body, and it is moving towards the center. So because of this, we notice that the charged particles forms a circular path. And this force which is acting on the charged particle, it's a centripetal force. So F is equal to m into v square by r. So according to the question, if the mass m1 is moving and forms a circular path, that time radius is r1. And similarly, when the mass m2 will pass, that time it will form a radius of r2. So if we take centripetal force due to the mass m1, so we can say that F1 is equal to m1 v1 square by r1. And what about F2 for the mass m2? F2 m2 v2 square by r2. Now we have to find the ratio of r1 by r2. So this force is our centripetal force, and this force is formed due to the motion of the charged particle and the presence of the magnetic field. So we know that F is equal to QVB. So this is our one relation and this is another relation. Let's take this as relation 1 and this is relation 2. So from relation 1 and 2, what we can write? From first and second, we can write m into v square by r is equal to QVB. Velocity cancelled, so radius is equal to mv by qb. So now if we have to find the value of r1, so we can write r1 is equal to m1 v1 by q into b, and r2 m2 v2 by qb. So now r1 by r2 is equal to m1 v1 by qb into m2 v2 and here qb. Charge is same and the magnetic field is same, so this gets cancelled. So from there we can say r1 by r2 is equal to m1 v1 by m2 v2. Now in the question, what is given? Both of them moving with the same potential. So what is the use of this relation? So let's see here. We know that when this is moving, we are applying certain work, and potential is equal to work upon charge. So work is equal to V into Q. And because of this work, what we are noticing? It forms a kinetic energy. So this work is nothing but the kinetic energy. So kinetic energy is equal to potential into charge. Kinetic energy is half into m into v square, potential into charge. So from there, v square is equal to 2 into potential into charge by m. So velocity of the first one is equal to how much? 2 times potential into charge by m1, and the velocity of the second one is equal to 2 vq by m2. So here velocity of the 1 by velocity of the 2, if we do the square over it, it's equal to 2 potential into charge by m1 into m2 by 2 vq. So this potential and the charge we can cancel because same. So from there we can say that v1 square by v2 square is equal to m2 by m1. So v1 by v2 is equal to how much? It's equal to root of m2 by m1 or root m2 by root m1. Now we substitute this relation in here. So it is equal to m1 by m2 into root of m2 by root of m1. So we can cancel this. So here we get the root. This we can cancel. Here we get the root. So from there we can say that r1 by r2 is equal to root of m1 by m2. So m1 by m2 is equal to r1 by r2 whole square. So this is the answer of this question.